Yeah, so let's start. Lasers and their efficient use. It was rather difficult for me to find a proper title to describe what I'm going to tell you today, because it's laser safety is one thing, of course, because this is what many people are concerned about, but there is much more about. To understand laser safety, actually, there's more things to be considered about lasers. So let's start. That's me. Basically, I'm more serious here than today. I'm the CMO of the Laserworld Group, so responsible for the marketing, the global marketing, and also for product development to a certain extent. I'm especially responsible for the software development and control development of this, and also for IT. Quite long here in the industry already, so quite some experience not only in lasers but also in lighting and sound, and also visual things as in general, like video and stuff. A short agenda, just to make you aware of what we're talking about. We have a company profile, understanding laser systems, different types of laser shows, think lasers from an effects perspective, so what you can actually do and achieve with them, how lasers work, how to find the right laser for your application, a laser systems close-up. I've got an open system here and will explain you how this is actually built, what components are inside, and what they actually do. We will have a close look at the laser show control software, but not for long, just a general overview so you see what's possible. And we will also talk about laser safety. I put that at last because it's important to understand the first things to understand the last point. Okay, let's have a look at the group, what we're doing, what's the company like. We're a manufacturer, distribution, and service company.
In the orange learning zone, Eddie Shorts is holding a panel for Come to Mobile. That's the orange learning zone.
Oh.
Now, Eddie Shorts holding a panel for Come to Mobile.
We get all these lovely interruptions.
Thank you, Eddie. Thank you, Eddie.
You're transmitting in orange, not blue one?
We should do. We should do
We
actually.
should hear about the blue room now.
Yeah, but there's no announcement for the blue room.
Yeah.
Actually, no. Okay, fine with that. Just, we're basically a manufacturer, distribution, and service company, so we provide a whole range of lasers, but we only do lasers, so we really specialized on lasers, so no lighting, no other lighting, no sound, just lasers. We got different company locations. We have some in Germany, also the main storage is in Germany. We got one in Asia, UK, Manchester, Poland, Japan, India, Turkey, Korea. There's many offices all around the world to cater the specific needs of the very market, which is rather difficult to handle. What's the general structure? We do the consumer show laser products. They're designed and developed in Switzerland with 100% pre-sales quality control, which is important to us. Of course, sometimes things happen during transport, but this is like with any other product. We have high-end production lines in Germany, which is RTI and TARM. It's the top-end laser systems that are usually used for these large-scale shows like festivals, multimedia shows on cruise ships, and kind of installation projects. And we have a product development department in Switzerland and also one in Germany. We do global sales. Global logistics hub is near Munich in Germany. We also cater for the UK market from there. At the moment, our UK distributors stocking up on products because they don't know what will happen, but actually we will still be in the UK market as we have the own office and also stock here. Several logistics hubs for Asia and Hong Kong and Shenzhen, China, to just cater for the Asian market. So we even ship the German and Swiss-made products to the Asian market because they actually demand for a German quality product, even in China, for the lasers. So this is an important side thing. Just an overview of the brands we carry. This is our own brands. We actually have Laserworld as the main brand, top-end brand, RTI and TARM. We have two software products. We have the Show Editor, which is the basic software product that comes for free with every laser you buy that has the ShowNET included, so from the diode series up. And we have the Show Controller as a professional software solution. We have the Laserworld Academy. It's our branch where we do all the education stuff, so laser safety officer trainings in general about general laser trainings, technical trainings, software trainings, all this. And we have the ShowNET as a technical mainboard solution for lasers now. More about that later. Understanding laser systems. I just want to give you an overview of what conventional lighting is like and what laser is like, because the best is to see the difference by just having a comparison to what you already know how light works. So, conventional lighting usually was controlled or is controlled with DMX or ArtNet, and you set a trigger signal and the light reacts to this trigger signal. On the laser side, it was the way that you put in a kind of a bulky 25-pin builder cable and send a control signal to the laser, because the lighting device has all the intelligence built in. So there's a main board inside the device that deals with how the gobos are projected, how the colors are projected, and everything can be triggered by DMX, but there is no intelligence transfer between the control and the device. With the laser, it was completely upside down. The laser was completely stupid. It didn't have any intelligence inside, and you put all the intelligence real time to the laser. So this was a situation since about a few years back, and it made it really difficult, especially for DJs, for mobile DJs, to work with lasers, because if you wanted to control them, it was rather difficult to do that. So you see that it's basically upside down. What we have now with the new generation of lasers, especially also with the professional lasers as well, not only with the basic ones, we have DMX and ArtNet as stupid control signal. It triggers, but we also have intelligent control signals. We have LAN as control option now, which can be intelligent or stupid, like with ArtNet, for example. It's kind of a stupid control if you do it one way. So the lasers became much more versatile during the past years, especially the professional ones. The basic ones, they used to have kind of, flickering effects with pre-made patterns inside, but there was nothing you could use in a professional manner. Now we have all the lasers with these features inside, and this changes a lot how you can use lasers and what you can do with lasers. Every DJ and entertainer can control lasers with integrated ShowNET mainboard without the need of any additional computer. So this is something that happens if you put intelligence into a device. The device can also act by itself. So it can be run in automatic mode, in sound to light mode. It can run standalone, like for projections, but you can also trigger it. It depends on the application. And especially mobile DJs, entertainers, also for nightclubs, they rather tend to have automatic mode, sound to light, or DMX control, but normally they don't want to do direct laser control like the laserists actually want to do it. So this is a different thing, but now it became very easy to do. So this is basically schematics how you can use it with ArtNet. You put just ArtNet cable, same with DMX, and trigger the contents on the laser. You can store content inside the laser. And this is something that is advantages for the laser against the normal lighting, because if you have a gobo inside a moving light, it's in there. If you want to change the gobo, you need to have another gobo made, and you put it in there, but it's rather static. With lasers, it's different, because you can put a custom gobo just on with your software. Just create it, make some artwork, and just load it to the laser, and it's instantly available. It can be colored, it can be animated, and it can do things that you cannot do with any other lighting device. And this is the special thing about lasers, and that's why it's so cool to have this new feature that you can load content on it and trigger it, because it gives you so much more versatility in how you can use lasers and how you can work it. I just have a video for you now. This is some sort of laser that is different to what I've talked about now. I've just talked about how you can create content and put it on. But I was always talking about a solitary laser. So it was one laser or two lasers. But times are changing at the moment because the lasers became so affordable. So many laser applications nowadays are mass applications. Because it's so easy, to just store content on it, to trigger this content and make many lasers do the same thing. Use DMX and use effects generators to create effects with it. And this is some the RTI Neo 6, showing the RTI Neo 6 here. But it's possible with any of these modern lasers. So you just put many of the lasers and you can create effects like that. No, not like that, not like that. Here we go. You get sound? No.
Turn the speakers off.
No, maybe I don't have sound here. I don't know why. Yeah. It doesn't matter. You can see it anywhere without sound. So what you see is it's individual laser heads basically, but you have effects that play together. So you not only have X-Y movement, but you also have patterns moving, and you have the movement towards each other. And it's kind of it's one effect, but created of many solitary units. So this is all controlled by DMX then, because it doesn't make sense to use any kind of computer control for this. As long as it's up to, let's say, 8 to 10 lasers, it makes sense to actually control it by computer. But if it's more, it's not a solitary laser that is the effect, but it's the mass of laser that creates the effect. Of course, this is not something you would normally do as a mobile DJ because it's still not that affordable. But just to give you an impression what you can do with lasers and how things are changing at the moment in the way lasers are used also by lighting designers. Let's have a look at the different types of laser shows. This is an important thing for many DJs. What I learned from standing at the exhibition booth, getting questions from people, is to understand how can lasers be used in terms of projection. Because there's different ways of the audience looking towards the laser, and they get different effects. So in this case, we have kind of a front projection effect. So the laser is pointing towards the surface, and it creates kind of graphics. So it's important that the graphics looks good and everything's fine, and it's kind of it's not a shape only, but it's kind of a graphics. This is one type of application. You do not need any fog or haze, you just need a surface to make that visible. The other option is a rear projection. It's like a rear projection screen. You project from the opposite direction and you just see the outline, and the projector is not visible to the audience. Then we have the rear projection. It's a translucent surface, kind of a mesh screen or gauze screen, where part of the laser travels through and part is reflected. This gives a sort of three-dimensional effect if you use like that. And then we have the atmospheric projection. So the audience looks the same way the laser beam goes, which is normal for outdoor projections like that, outdoor effects, if you do outdoor effects. And then we have the classical beam show, where the audience looks towards the laser beams. You can imagine that each of these projection types has different challenges to do and different implications on laser safety. You can imagine that this type is the most dangerous one. If you talk about danger, this one also needs to be considered because people face the laser. The other ones are more or less safe. But depending on what you want to achieve, there's different ways of working with lasers. For example, if you work as a wedding DJ and you want to write, say, hey, congratulations, this and this is whatever, this should be something you would probably want to do, or this. That's the two types of projection you usually go for, normally this one. It's super easy to do. You don't need fog or haze for this. It's just a surface you need to project on the wall, ceiling, wherever. If you have an outdoor thing where you shoot beams and want to track people, you probably go for something like this. The challenge for doing this is you need really high power for doing it, because the visibility of the beam cannot be controlled with fog or haze in this case. In many cases, it's outdoor. It's just the normal moisture in the air that you use for making the beam visible, so you need high power. It's not the common application in a mobile DJ job, so this is not that common. But this type is rather common. You have a beam show. You can do this beam show with hitting the audience or without hitting the audience. It's two different aspects. So if you just keep the beams overhead, everything's fine. There is no danger in terms of laser safety, but the thing is you need more for light and the particles glow, and this is how we can see light. So this also affects all other applications. If you use lighting effects as mobile DJ, they will only work properly if you have fog or haze in the room, which is a problem with many venues because they would not allow it. But normally, if you want to have a proper light show, you need fog or haze to make that visible. Otherwise, people get struck by light, but they don't see the light coming. So it's kind of more flashy, but not the emotionalizing effect you usually want to have with people with lighting that actually strikes the audience. Because there's two different types of lighting. I'm not sure if you're aware of that, but you have like video walls. You have video walls, huge video walls, but they make lighting in an ambient way. So they make bright. You have bright in different color shades, but it's no effect lighting. With moving lights or with these effects lights you normally use as mobile DJ, you face the audience and people get struck by the light. And this is an emotional lighting, it's an effects lighting. And it's a huge difference between those two. Because if you have a nightclub and you only have video walls around it, it's super bright, but it's like that people won't dance because it's not emotionalizing to a certain extent. It's really difficult. But if you have moving lights, if you have kind of effects that strike people, it's much more emotionalizing. And if you have fog or haze, this becomes more visible. The same is with lasers. So if you use lasers for emotionalizing people, it of course makes sense to use this kind of beam show and to use fog or haze to make things visible. So this is important to understand because I'm basically more a lighting guy than a sound guy, so I always stand for lighting and say, hey, you need to get more lighting to emotionalize people at your events. And I think this is an important thing because many people focus on the sound only, but if people are drunk after half an hour, they won't care about the sound, they will care about the lighting because it emotionalizes them in a different way. But this is my opinion, you know, I've experienced that for quite a while, especially in nightclubs. They spend, I think you know it best, they spend 200,000 quid for sound system, and then there is no money for lighting anymore. And this is difficult because in the end, lighting is so important. Let's continue. Projection, surface, and fog. As I said, lasers always need some sort of surface to be visible. Solid surface for projection purposes, particle in the air that reflect the light like fog or haze or natural mist or dust. Projection surfaces for lasers, projection can be projection screen, boards, mesh screen, wall, whatever statue kind of thing. There's many options. For audience beam shows, it's essential to have sufficient fog or haze. I just write it that way, sometimes it's not possible, but you will not see laser effects if you don't have any particles. It's simply, yeah, it doesn't make sense. There's a typo with types. Not every type of laser show can be controlled the same way. It always needs to be determined which is the best control option to achieve the goal. As I said previously, you as mobile DJs or DJs in nightclubs usually use automatic mode, sound to light mode, or DMX control if you want to really get control of lighting. There is only a few people that use actual laser control software for controlling lasers in these venues. And this is okay, because it all depends on the type of application you have, which control option you should go for. So for lasers, DJs, entertainers, it's the standalone operation. For live productions, if it's only a few laser systems, up to 10 laser systems, it makes sense to use a laser control software because you have much more control of what's actually happening. It's not just triggering content, it's creating content on the fly. If you have a music or media synchronous laser show, usually you use laser show control software. Maybe some of you do not know what this is about or what you can do with it, but this is something that's important to know, because this is something where you as mobile DJs or DJs in general, entertainers, can make additional money. Because if you show up at a venue and you're the DJ, you're booked as DJ, then you do the DJing, you're already there, you set your kit up, you probably even bring a laser with you, but it's kind of included in the package. But if you come there and say, hey, I've got something special for you, I can do a laser show, which is not, you know, having a flickering laser up there, which is an actual laser show with music synchronous. You select the music track and then the lasers go up, and you make a proper laser show. This is something you can sell in addition to your DJ package, because it's rather, yeah, it's rather affordable for the customer because you're already on site, so they only pay travel expenses once. You're already on site, you have the sound system already plugged in, and it's not much extra effort to do that. So what we have is, with both software and products we offer, so even with the one included with the laser, there's 250 free shows coming with the software. So it's super easy to offer to a customer, say, hey, I've got 250 shows, select one, and we do the show for plus some extra money. And I'm confident that people will go for at least a certain percentage. And this is something you can add to your show. And this is it's all about making money in the end. And this is what really helps beef up certain setups. For example, you all know Jonathan Lewis, probably, the DJ tutor. He did that, so he bought some units and is now beefing up his setup by doing this. He's some positively crazy kind of guy, but he does this and really learn about how to use the lasers and to make extra money with them. And it's quite interesting to do that. I know it from other countries, but in the UK it's not that common yet, but it's upcoming. Think lasers from an effects perspective. Just showing you some pictures what's possible. This was Shanghai Expo. This is in Russia. It's in Romania. Some other effects. Logo projection. That was an industrial event I did for a company. They had kind of a company event, and I did the logo projection and stuff in combination with video projection. The other picture is from a multimedia installation in China. That's some hydro shield, it's water spraying from below, and you can project onto it with laser and video combination. We've got laser projections towards water surface. We've got laser in combination with fire, with water shield, and with video projection. So there's many applications you can do with lasers. Just to give you an impression, this is nothing you do in a mobile DJ context, but this, for example, is something you can sell additionally to your normal DJing thing, because you can support companies by bringing out their logo or by emphasizing their brand. This is some sort of outdoor event. It was in Marseille in France, where they had kind of cultural capital of the world or whatever, several years ago. This was some strong lasers connecting 5 cities in France. This is the other perspective. So you see it's a different perspective, looking towards the laser like this. This is on top of the headquarters in Switzerland. And this is was a festival I did this year. We used several lasers, and you see how the lasers actually emphasize the whole setup. You couldn't do it with normal lighting like this. It's not possible. It's technically not possible to focus lighting in a way the laser actually creates light. So these were several 10-watt units, 2.5-watt units, and 10-watt in the center. It was quite a nice festival. This is more the situation you're facing, kind of a dancing crowd, smaller room. And this is how you can use lasers. This was a safe laser use. I did it myself, so I know it was safe. Also involving the crowd. I'm just giving you a short. It was very early in the morning. Most people have left already, so that's why. But I chose this part of the video because you can see the lasers properly, because there's not so many people in there anymore. So you see we reduced most of the ambient lighting and just used the emotionalizing laser lighting for the effects. You cannot see properly, but there is a safety zone set in the software, so the lower part is reduced in power, in order the higher part shoots above the head with full power, so nobody gets harmed.
That's just using the two lasers.
Basically, it's the two lasers. There was another one in the center. I switched it off because it was too dangerous. I put that one off. It's just the two lasers.
Which model are those?
Those were the DDS 2000, I think.
What about splitting the beam to mirrors?
This used to be a thing in the past. This was due to you only had more or less one laser source. You have the gas lasers, one tube, you have the scanner heads, and you needed to get the beam from different positions, but they were super expensive. So the lasers were super expensive, and then you use the mirrors to just make the beams bounce. Nowadays, as the lasers are rather affordable, you just use more lasers.
Right.
Because it's a pain in the ass to actually align these mirrors, because they become misaligned by time, especially if there's bass moving, you know, and sounds getting and everything's shaking, they misalign, and this is rather difficult. It can work for one night, for 2 nights, but especially if you do an install, it's simply difficult to handle. That's why normally you don't do it anymore. I like it very much. I like it because it's super cool, but it's so much work to actually align it, to position it, that people normally don't do it anymore. But it's a cool effect. It's a cool effect.
Would you have to have the lasers continually moving in this scenario, or do just say you can just leave the lasers where they are?
What do you mean continuously? The effects moving, or?
Yeah, the effect moving for safety reasons, really. So just leave them as they are.
In fact, if the effect is moving, it's a safer thing than if you just make it standing, because you have the movement traveling over the eye. But this was not the case here, because it would have been safe anyway. Because I just chose those patterns that were safe. It's a matter of choice of patterns if it's safe or not, to a certain extent. I will explain that later a bit, because it's important to understand that. In this case, the movement was just because the music was the way, and I only chose the parts of this event where we actually had the lasers going, because there were parts, of course, where the lasers were off in between, but just have the moving lights. Just depends on the type of music and the customers actually, if they're dancing or not. And you know it best how it works with customers. If you see how they react to something, then you switch it on, and if it changes, you just choose another music style or whatever. It's the same with lighting. How lasers work. How do lasers work? Why are they different to conventional lighting? What are the opportunities of lasers? What are the limitations of lasers? Why are lasers different to conventional lighting? Laser light is extremely focused with high energy density in one spot. It is primarily focused by the way it's created, not by additional optics. This is also important, because if you look at a super sharpie or something like that, or mega pointy, where the super thin, high power moving lights are in the market now, those effects are created from conventional lighting sources by using optics to focus. But this physically is limited to a certain extent. That's why we cannot narrow it down anymore, because it's just the way the lighting is created, because the light in those units is created radially. Like with a discharge lamp or even with an LED, you have quite some angle it is created. With laser lighting, it's completely different. It's created coherently, so you have all the light go in one direction with one wavelength, and that's why it's so super focused. So comparing a conventional light bulb, I call it light bulb, it doesn't matter if it's a discharge lamp or what, but it creates light radially. So you've got a kind of a deflection angle, which is rather big. So all the energy you put in here goes to a certain area at that distance. So it's distributed to a certain area. With laser, you put in energy here, and it literally comes up with the same energy here, more or less. You just have a very, very low divergence. And this is what makes lasers so dangerous. So even if you have a 100-watt light bulb, it's not dangerous to look into it, because the 100-watt is all spread radially. If we have a 100-watt laser, whoa, that's some sort of laser. So this is super expensive, super dangerous. So even if we have a laser with 100 milliwatt, this one, if you just make a single beam, it will travel. If it's a green one, you can see it from kilometers distance, probably. So the thing is, the energy density is so high in one spot that there is where the danger comes from, because it's already made dangerous inside the unit, but we like the effect. So we need to deal with it. But this is the reason why you cannot create light laser. There have been some effects machines that try to create laser light in a way, or simulate laser light with LED, but it doesn't work out because you do not have the efficiency of an actual laser source. This is a completely different technology. This explains why it is so focused light amplification by stimulated emission of radiation, and this is where the coherence comes from. So if we compare it, we have a conventional lighting device. It quickly loses intensity over distance. So if you have a festival and you have the normal moving lights going up, in the front rows it's all fine, they get struck by the light, everything is emotionalized, but if you go to the back of the venue, you will see that it's not reaching there anymore, especially if it's outdoors. But with lasers, you can reach there. Lasers may look similar, but they are not. They all have black boxes from the outside, so you see they all look similar, but it's the inside that counts. Many technical aspects can make a difference in the quality of a laser system. Most lasers look similar from their housing, but the technology inside is decisive. Do not fall for the total power values given. So this is most important. So if you want to go for a laser, do not go and say, hey, I want to have a 100-watt laser, 100 milliwatt laser. Because it simply doesn't say anything about the laser. It's like if you go shopping for loudspeakers. Do you go for a loudspeaker and say, I want to have a 2,000-watt loudspeaker? Do you do that? It doesn't make any sense, because you do not know anything about the quality, and you do not know anything about the efficiency. Because in the old days, when we didn't have the active speakers, but kind of passive speakers, we needed to put the actual amplifier to run the bass bins and the speakers. And if you had a speaker that consumed 2,000 watts of power, you needed to have a proper amplifier to cope with this. And the efficient speakers, they didn't have the 2,000 watt. They have 300 watts. And you can use a smaller amplifier for it, because they were more efficient. And this is something you need to consider when also selecting a laser device. It's not about the total power. So, if you want to select a laser in terms of the power values, look for visibility. Because visibility is what counts in the end. It's not the power you push towards somebody, it's the visibility, so you see the beams without having any danger to people. So, if you select a laser, look for the portion of green. Because green is the most visible color to human eye in terms of lasers. So this is just a generic product with the values. So I give you an overview of what the specifications are. So we have total power values. There's the total power values, which is the total power, which is the overall power inside the laser, an addition of the power of the modules. And we have the total power at aperture, which means this is the power that's actually measured here, coming out here, which is the important one. It's not the one inside, it's the one coming out of it. Then we have power red, green, and blue. These are the sources inside. So it's, hey, I have a white laser. Yeah. Laser light has the specification by being coherent, and normally laser light is only available in one color. Due to the coherence, this means that the beam is also only in one wavelength, meaning one color. So you have a green source, a blue source, and a red source, usually in those lasers we're talking about here. There is other lasers with other colors, but this is more difficult to deal with. So this is red, green, and blue, and they are matched up and create the white light. And by dimming those individual color channels, you can create different color shades. This is how the laser actually works. So we have 3 values given, red, green, and blue. In this case, 200 milliwatt, 200, and 600 blue. Then we have the beam specifications. In this case, it's the full angle, which means that these are the actual values, not the half values. It's a bit difficult to explain, but I've written a tutorial on this, what the difference is on our website, if you want to read that. So this goes for the beam diameter and the divergence, so the spreading of the beam over distance. This is an important value, because this says something about the quality of the laser and the usability of the laser. If you have a certain size of the laser beam at aperture, this means that the beam is that thick when it hits the mirrors that create the imagery in the laser. The thicker it is, the bigger scanner mirrors you need. Bigger scanner mirrors mean that you have higher inertia, because the motors need to move these mirrors, because it's a mechanical deflection thing. It's not like with the old TV screens where there was electrons that were deflected, but in this case it's a mechanical thing. And the bigger the mirrors, the slower the scanners can go due to inertia. So if you want to have a fast scanning system, you need a small beam with small mirrors. And then we have the millirad, which is the divergence. It means the widening of the beam over distance. The smaller this value, the better, especially if it comes to long distance projection, because this multiplies over distance. This is a static value, so it gets that bottom value, and the other one goes exponential. So the smaller this one, the better. The problem is, I can reduce this value by increasing this value and the other way around, which is difficult. I do not explain that too much in detail because it's very technical, but you cannot do that. You cannot play around too much with it. It's kind of limited. So just have a look. If you get good values here, you can normally assume it's a good laser system compared with the values here. Then we have laser sources. It's diode and DPSS laser. DPSS laser is kind of a bridge technology between the gas lasers and the diode systems, and it's only used in the basic lasers nowadays. All the more professional ones have only diode sources. It's kind of a semiconductor technology comparable to LEDs. Yeah, in the way lighting is created. Operation modes. We have information about the scanner system. There's the Galvo system. It says a value about the kpps, which means the kilopoint per second. This gives some impression about how fast the scanners are actually working and if they're capable of doing graphics or not. Everything above, let's say, 20 kpps is graphics capable. But there's more to these values, which are normally not given, which basically determine how good the scanner is, but this is nothing we want to talk today.
So with the 3B laser, how do you position the diodes at the front? Are they just literally next to each other like that, or are they in a circle? Or?
Basically, we use so-called dichroic filters to get them match up. So we have one green diode source usually that comes straight towards the scanners, and then we have a red one that is 90 degrees, and we have a dichroic filter that lets pass the green beam and reflects the red beam. Yeah, and the next one just lets pass the green and red and just reflects the blue. So we add them up to one beam, and this is how it actually works.
So do we need to clean that?
Yes, normally you should clean your laser systems from time to time, because there can be residue from fog or haze fluid, or just from normal, moisture, dust, whatever. So it makes sense to clean from time to time.
I guess there's a risk of knocking the angle of that.
Yeah, it's like with everything you clean, you can knock it off. Be careful with it. I think we have some cleaning instructions on the website. I'm not sure, but just be careful with it. You can use some Q-tips to just clean it, and normal water is sufficient. Do not use any cleaning liquids. Strong cleaning liquids. It can damage the coating of these dichroic filters. That can be a problem.
Not compressed air.
You can use compressed air, but do not blow towards the dichroic filters because they can just break them, because they're rather thin. But you can use it for the electronics to just clean the electronics. But if you
that won't get rid of fog though, air. Air won't get rid of fog residue.
oh, normally should. Yeah. If you have fog residue in here, it depends on the unit. Most units are dustproof now, so you don't have any circulation inside, so you shouldn't have any fog fluid inside. But if you have, normally it's kind of like dust hanging there, it should work. So you can get it out. But just if you use compressed air for cleaning, make sure to always block the fans and not let the fans run with compressed air, because the fans will die with doing that. It's the same with all lighting devices, sound devices. If you clean it with compressed air, just block the fans from turning by doing it. Okay, so this is a chart that shows the general visibility of different color spectrums to human eye. And this is important to understand what I said before. If you choose a laser system, look for the portion of green, because green is the most visible color. It's like green, yellowish, something like that, but we don't have the yellow spectrum, so for us green is the most visible spectrum. And you can see the number of times it is more visible than blue or red. It's multiple times more visible. And therefore, look for the portion of green to determine the actual visibility, because if you compare this between two units, you usually can actually find out which one is better visible, even if the total values given are the same. And you will be surprised what this difference could be. This is just giving you some overview of the wavelength span, red, green, and blue, what the spans are. Not too important to you, because it doesn't influence on your decision for lasers. Just giving you some more technical background, because I think some of you might be interested in some in-depth technical things about professional laser systems. The problem is with lasers that we have these little laser diodes, laser sources, and the technology is not equal for every color. So to create a color, you need to have a certain active material to actively create this color. So there is a limitation, especially in red and green, in terms of what maximum power per single laser source is possible, technically possible. So for the red ones, we have about 170 milliwatt. There is stronger ones now, but they have different characteristics and stuff. But if we only have 170 milliwatt per source, we need to combine them to get more power. You can imagine we have lasers with up to 90 watt in total power, which is massive, and they have a portion of about 30 watt red or so. So you can imagine what this means. You need to make 30 watt red just out of 170 milliwatt single diodes. You can imagine what this means. And this is where these massive modules are built. And this is how it actually works. So we have these modules and these laser diodes, and they actually create a beam, and the next beam is just knife edge, it's so-called knife edge combination with another mirror to be exactly side by side with the other beam. And there is another thing that you can do. You have two polarizations, A and B, and you can combine these to exactly match on top of each other. But this is only possible once. You have only polarization A and B. So by creating large arrays of lasers, this becomes very, very technical, and this is where our high-end development in Germany comes to the game, because they are specialized in doing these kind of high-end laser modules. This is nothing you normally would have to deal with, because in the lasers you usually get, it's only about up to 4 red diodes normally. There's not many more. But if it becomes more complex, you can imagine how difficult it is to actually build something like that, because it's not a millimeter, it's a micrometer that you actually have to consider when assigning these, when aligning these mirrors. So it's a very, very difficult thing to do. The challenge is, as we heard before, if we have a thick beam, we need to have bigger scanner mirrors, and we get high inertia, we get bad scanning. So this is another thing we need to deal with. So the more diodes you combine, the thicker the beam gets. It's a challenge. So it's not like normal lighting devices we're dealing with. It's a very sensitive thing, the laser. Just briefly going through the scanners, that's the deflection devices. where we shoot the lasers to. We have an X and Y scanner, and they move pretty fast, and that's how they create the imagery, basically. So let's have a look at the control options, what we actually have. I initially explained to you that we have software option, we have ArtNet, we have a built-in SD card where you can store own content, music, sound to light, standalone, DMX, master slave, and this is all in the new main board we use for the diode series and higher products. So this is awesome because it gives you so many options to control the laser and to use the laser. You can use it for advertising purposes. You just place it somewhere and have a logo of a company projected towards a wall during their whatever festivities. Or you can have a wedding where you project congratulations Mr. and Mrs. You can just have that standalone. But you can use it also with DMX if the people are dancing, you want to act the extra effect control with DMX, you have full control of the speed, of color, kind of rotation effects, select different patterns. So many options you have by controlling that. And if you want to do a laser show and really want to emphasize people with just doing a specific laser show, you can use the software. This one's for free with a main board, and the other one is a paid one, a professional one, and just, you know, add the extra thing to your show.
Is it possible to get a demo version of the show controller so you
Yes.
can compare the two?
Yes, you can download it on the website. So the one website is showeditor.com and the other one is showcontroller.com. So easy one. Okay, so I want to do a short laser systems close-up so you understand what the laser system is about and what features do we have in it. This is one generic laser system. I think it's this should be a DS1000 RGB or 2000, something like that.
Ladies and gentlemen, we'll shortly reopening the sound experience with Bishop Sound at 1450. Followed by DAS, FPT, DB Technologies, and so on in the normal order.
Okay, good. So,
The sound demonstration room is now reopened with Bishop Sound at 1450.
very good. So back to the laser experience. It's basically a DS2000, 3000 unit. So what we have on here is we have a microphone thing, we have scan safety, so we can kind of block the unit from making a single beam, which is an important thing to consider in terms of safety. We have x-axis and y-axis movement. So for example, if we have two lasers, we can just flip it on the x-axis and it just runs like this. It doesn't run like this, but it runs like this. So the effect you have with only one control is spreading on two units. This is how we did it in the past if we had only one content source and wanted to use it on two lasers. Nowadays you can individually control them, so you don't necessarily need to do that. Here you can balance the color of the lasers. You have red, green, and blue. It's kind of a trim pot. So you can balance the white. So if you have 2 or 3 lasers, you can make them all the same white. This is the physical one. You can do the same thing with software, but of course if you have it run in auto mode or sound to light mode, there is no way of, you know, kind of accessing software to actually balance it, so you can do that at the unit. Then we have the LAN, the ShowNET connector. It's just a normal LAN cable, Cat5 cable, Cat6 cable, whatever you have. You plug it in. You can control it with ArtNet through that, or you can also control it through the computer, or you can upload content to the ShowNET, or do settings on the ShowNET. There's different settings inside. This is, it looks kind of old-fashioned having a dip switch board on it, but we needed to find a way to make all the features accessible by manually selecting them. We considered a display, but the thing is that we will bring out so many new firmwares and the firmware updates in the future that add new features to the ShowNET, which is super simple. We just connect to the computer, do the firmware upgrade, and you have new features in the laser, that we would have to upgrade the display as well. And this is a difficult thing because it's not linked to each other, and you would have to exchange the display then. But by using the dip switches, it's so easy to do, and we can just add new features. That's why it's still with the dip switches. We have the key switch, makes sense, key switch, and we have interlock in, and this normally doesn't make sense to most people at all. I have a key switch, okay, but the laser's hanging up there in a nightclub, 6 meters high. Why should I have a key switch there? And also, what's the interlock? What's it for? Because the laser gets delivered with kind of, you know, this plug. You plug it in, it works. Why is it there? Reason for this is safety regulatory, international safety regulatory, IEC 6825, which regulates all laser safety things, and not only for show laser lighting, but also for all lasers. Medical lasers, industrial lasers, everything. And if you imagine you have a huge laser cutting machine in an industrial use thing like automobile industry, it cuts through metal, and of course you must make sure that nobody can operate it without permission. So if the operator needs to go to the toilet, he needs to be able to lock the system. And the same is with an emergency stop, which is the interlock thing. You need to be able to e-stop the machine if something happens. And this is where all this comes from. It only makes sense to a certain extent for show lasers. It makes sense to have an e-stop with it. That's a system like that. You can attach it, and if something happens, shut the system off. Why would you do that? Normally, you operate in a safe way, nothing happens. But imagine you have mounted everything to a structure and people start climbing the structure because they're drunk. Then of course you need to be able to shut off the system. The same is if, for example, people step on other people's shoulders and try to grab the laser. Because you can imagine, you have everything safe. You have a super strong laser, just everything's overhead, beams are just moving, everything's fine, people are dancing. And some drunk guy tries to bend down the laser. What happens if he bends down the laser? People get struck by laser light from above, and what do you do if you get struck? Automatically look that direction. And this can be super dangerous. That's why you need to have an e-stop, so you can shut off the system if something happens. This basically applies to the super dangerous lasers. If you have a +2 laser or something, kind of star effect thing. It's not done, but it's for the stronger ones. And this is where all this regulatory comes from. So what we have is DMX in and out. We have builder in and out, the old type connector, so you can use external interfaces with it. And of course, normal power.
So for this one, you just have the key. You don't have to put that pin in the back.
Both. This one, basically, at this laser, it's that one. At this laser, it's just a normal LAN cable. It's a LAN cable. This is a direct wire into this. There's an adapter for this one. And then you can use it as e-stop.
Do you have to have the emergency to operate the laser, or can that just be hot lines?
There's different solution for doing e-stops. There's the one interlock e-stop solution I just talked about, and there's also the option to use power cutoff. So you just use a button like this to just interrupt the power. This is also possible. It depends on the country if this is accepted or not. It depends on authorities if they want something like that. In fact, in the UK, it's no, there is regulatory, but it's not prosecuted in a way. It's a bit difficult to handle. I recommend to have either the power e-stop or the interlock e-stop to just be safe and be according to regulatory. Because it's in the regulatory that you have to have it, so you should have it. And it definitely makes sense.
If you use DMX signal,
yeah.
will it just go to sleep? Is that another power?
It is an option to just deactivate the laser, but it's not accepted as e-stop solution because it can fail, and therefore it's not accepted. Anyway, what I do, I usually use a power e-stop. So I just have an e-stop, get the power down, and then just daisy chain the power cable through all the lasers, so I can just immediately shut it off and turn it on again if necessary. That's the easiest way to go.
But you don't, on these lasers, you don't have power in and out, do you?
It depends on the model. On this one, we don't have it because there's no space, because they're so small. We don't have space to put another plug. On the Tarns, we have it because they're bigger housing that it fits in. Laser show control software. So laser show control software is not only laser show control, meaning active live control, but it's also where you can create content that you can store on inside the laser to be triggered later. So it's not only making live shows, but also preparing content with the software. The ShowNET software is included with every laser that has the ShowNET included. And you have a free full version. There is 250 free shows coming with it. We have a live laser show control. We have timeline-based things. We can trigger it by on-net or DMX, so you can even trigger the software. So there's more options for control. And we have multi-interface support, and you can create both logos, text, and artworks. So there's converters for that. Yeah.
If I bought one with a ShowNET thing, but then decided to buy one of the lower price ones, like the CS1000, would that software still work on the CS1000? Or?
No, it won't, because the CS1000 doesn't have an integrated DAC, it's called digital analog converter, because we still need the signal to be analog for actually driving the laser sources inside and the scanners inside. So what we need to do is we need to have a device that actually converts the digital signal back to an analog signal. The ShowNET does this in the units, but if you don't have the ShowNET included, you need to get an external ShowNET for dealing with it, and then you also have the software with it, and it works. The external ShowNET, I have one with me. It's just a small box, and looks like that.
Yeah, I've used Pango.
It brings some additional features, the external one, but basically this one works because you have all these lasers. You have still the builder input, like these 25-pin wires. We have short ones. We can just put it on top, and that's it.
Okay.
And you can, with using the external interfaces, you can also use one interface for several lasers. If you have all the lasers, you can just daisy chain them on the inner chain. That's possible with the external interface. So the show controller, that's the more professional software solution. This is what we use for large-scale productions and installation projects. There is a really good live interface, but also real-time, which is the timeline program, Pighead, where you can make own artwork, Tracer for converting JPEG, bitmap images, and SVG for importing vector graphics and even vector animations. So this is something, a very versatile software suite, and we're using that. I'm using that pretty often, and it's a really professional one. We have that on display at our booth, A4, so you can give it a try and see how it works if you like to. So let's have a look at laser safety. I think I'm still in time. But we don't have any limits.
We don't have a finish time, so as long as you're happy.
Just let me know if I bore you. So.
Want to go and buy some stuff?
Oh yeah, no problem. We're open till midnight for that. No problem. So, for laser safety, talking about laser safety, we already talked about several aspects of laser safety in here. Laser safety, if you think about laser safety and you consider that and you think, oh, what do I probably need to do? You're already 90% safe. Because most people that are really doing dangerous stuff, they don't think about it at all. So thinking about it is already the first thing and most important, and then it's all fine. Risk assessment is always required when using lasers in a professional environment. Meaning risk assessment, we just think what could potentially happen. Just make your mind of what could potentially happen. If you're in a room like this and have lasers up, for example, what can happen is we have the mirrors up there in the lamps, and they can reflect laser light. Laser light could potentially exit out of the window. We cannot have that in traffic, so might be a thing to consider. What could we else consider? Yeah, we need to have a certain height for the laser so people cannot touch it, because if people can touch the light, they can bend it down, they can, kind of have reflective rings, watches, whatever that can reflect laser light, something like that. So it's just some basic stuff, thinking of it as just reasonable things. I will have a list afterwards so you can see what to check on. In most places around the world, there is no license required to actually operate lasers.
More expensive.
It is good and bad at the same time. In Germany, Austria, Switzerland, and Singapore, it is required. Switzerland from next year on, so from December next year, there's the strictest regulatory for laser shows in Switzerland, but only for shows. In Germany, it's a general law. In Austria, it's a general law for lasers, and in Singapore as well. Singapore is some fancy stuff I experienced there. It's kind of weird, but okay. A typical requirement for mounting is 3 meter height above the ground if people can move close. So if people can move under the laser, dancing under the laser, internationally you're required to have 3 meters height. Internationally, in Germany it's 2.70 meters, internationally it's 3 meters. Of course, if you have a stage and people cannot move close, you can move it lower, as long as you do not exceed the MPE in the audience. The 3 meter rule can be adjusted depending on audience scanning level. MPE is the maximum permissible exposure. It's the maximum output power allowed in the audience area. This is maximum about 1 milliwatt emission. The power of a show laser system significantly reduces with the distance of the audience to the laser. So the distance makes a huge difference under normal circumstances. We heard before that if we have a laser beam, it does not lose power too much over distance. It just goes, goes, goes. So if I have a nightclub environment or a mobile DJ environment, I use certain patterns to shine towards people. If I shine a single beam towards people, it will of course be super dangerous, and you can make safety zones or whatever power reduction, it will not help, because shooting a 1 watt beam towards the audience will be 1 watt in the audience, at least at close distance. So if you then consider doing just a circle, it's a completely different thing, because the circle, at the beginning the circle is rather small. So the whole power of the circle is on a small area. But the farther you go away, the circle widens up, and the whole power is distributed over the long journey that the beam travels around. Because we heard before that the laser light is deflected by the scanners. So it's just one beam that moves pretty fast. And the faster it travels and the faster it moves, the less is the duration on human eye. So the faster it moves, the less dangerous it is. So by, for example, making a circle projection, and if it goes for a longer distance, you lose a lot of power on it and it becomes safe. But by doing a single beam, it's not. So it's all about the operator to make it safe by using a proper projection, proper patterns, and properly doing it. We will see that in the software. I'll show you some tricks to make that even safer. So this is important to consider. This is not like in video projectors. In a video projector, if I want to have a single dot, I just blank out the rest and just make a single dot. But the single dot will not be brighter than if I just leave it like that. It will not be brighter because it doesn't accumulate, it's just kind of a cutoff. But with laser, it's different. Lasers usually use the full power on the whole travel path they have available. So if there is no travel path for the beam, it's just one beam, there will be the full power in the beam. If you make 4 beams, the whole power will distribute on these 4 beams. So the individual beam will be less bright, possible due to a new way of kind of creating it, but this is just, it can just do certain effects. It's kind of a star effect. But it cannot do, of course, the nice, beautiful scan effects. To understand the risk of emitted radiation, lasers are divided into 4 laser classes. So it starts with class 1 up to class 4. Unfortunately, the really cool lasers are all class 4 or at least class 3B. So we are in a potentially dangerous range, unfortunately. But as always, like with a chainsaw or with a car, if you know how to operate it and you're confident with what you're doing, you can do it in a safe way. The classification is done to the IEC 6825, which is the international regulatory, we heard of that before. So let's have a look at the laser safety areas. I talked about the 3 meters height before, and this is something that basically applies to bigger venues and more powerful lasers. So if you have 10 watt laser or something, of course it's important to consider that if there's kind of an audience seating that goes up, we need to consider that we need to keep the really, really hot beams above this 3 meter level also when the audience seating kind of elevates. But actually, with normal lasers, if you have a certain distance, it will not be a problem to kind of scan the audience if you do it properly. If you do safety zones, if you reduce the power there. If the limit of the allowed radiation won't be exceeded, the laser is used in a safe way. The distance is one of the most important variables of for this topic. Here we are at the software safety zones using a laser. So I brought a laser with me, firing it up. Switching to the software. And here we are. This is just a normal spiral projection. And you see it's a bit more intense here in the beam because there's more points drawn. So this is the most dangerous part of this projection. And now I want to shine this towards the audience. And there's a feature that's rather, I think every laser control software has this feature. We now have it also for DMX control and ArcNet. All these new units with a new main board, you can also do safety zones with DMX or ArcNet, which is super cool because on site you probably have a DMX control, but you not always have computer control because it's kind of bulky. If you're a mobile DJ, you just want to get going quickly and you don't want to fumble around with software. But I'll show it to you with software so you can actually see how it works. So in the software I have a horizontal safety zone feature, and I can just reduce the power. You see that on the lower end? I can completely switch it off. I can leave it on a bit, slightly bit. So this way will probably be fully okay in terms of safety. Because we reduce the power, it still keeps the color to a certain extent. And if you look towards the laser, you will probably not even see it. But if you look from a far distance, you will see the effect that it will be really bright above the heads. So this is something you can do. You can add more safety zones like this. For example, I put an individual safety zone like this. And you see I blacked out a part of this spiral. And this is how you can actually make it safe. And just move it around, put it somewhere. This way I can also set blackout areas. For example, if you have a video projector or a camera in the room, make sure to not hit them with full power. Because the video projectors, they have a lens in front and they have kind of a display matrix inside. So the lens is actually like a burning glass. And if you shoot with a laser through the lens, the whole intensity of the beam will be focused onto the projection matrix. And this will kill it, basically, or at least some pixels. The same with cameras. Just be aware that this can happen. Even though it may not be harmful to the human eye, it can still, if you have a camera zoom, and you zoom into it, it can still be harmful because it's kind of the burning glass effect. And this is something to be considered. That's why it makes sense if you have a camera on site, just blank it out. That's it. So this is how it works. So we have this safety zone, and this is something that is a global setting. So if I, for example, add a rotation to this one, it's still preserved. So you see the rotation going, and it's still reduced in this area. So it's a global thing. It's nothing that is kind of pattern specific, it's a global setting. And it's very easy to do, basically. If you consider doing it with DMX or ArcNet, it's simply 2 faders. One fader specifies if the safety zone comes from the lower end, comes from up or left or right, and the second fader specifies the intensity for the safety zone specified. So it's a bit more limited in what you can do with DMX or ArcNet, but there will be future things that you can do more of that with the new firmware upgrades that will be coming in the next months. So, just summarizing the potential risks. Be careful when working with and at the laser. Risks to be respected during operating or installing the projectors. Tools, do not use any reflective tools. So, I just do something you shouldn't do. I have a watch and you can see I can reflect the laser light with my watch. It's dangerous. You can also use reflective tools like a screwdriver or whatever. The closer you are to the laser, the more dangerous it is. Also, do not wear watches, rings, bracelets. If you adjust something at the open device, like color balance, you know, color convergence, so basically red, green, and blue are like this, and you need to want to put them back to a light point, you need to work at the unit basically. Do not bend over the device. This one has a protective cover above the scanners, but there will always be radiation coming out of the scanner block facing up, so that's always dangerous, so be careful about that. Installation at truss, if you install the laser, make sure it doesn't start automatically. So you just have to step back to your desk and then remotely start the laser. This is an important thing because if it starts automatically, somebody that is close to the laser may be harmed. Installation by experienced people, I told you before. People inside the safety areas, make sure that do not exceed the MPE. Cameras, projector, screen, I talked about. Just want to give you a short head up on the Laserworld product portfolio because we talked about the different lasers before. This is something from the high-end range, so you see how complex these high-end lasers are with some sort of digital displays per laser driver and all this, so this is a rather complex product, very expensive, but we of course carry different product levels. So normally these units here are perfect for mobile DJs because on the one hand they're durable units, really reliable units, and on the other hand they're really maintenance friendly and affordable. Those ones are the entry-level ones. They work well for mobile DJs as well, but we have many more possibilities and opportunities with these units. So these are the top-selling ranges like the Club series and the Diode series at the moment. Of course, if you go for more professional applications like projections, advertising, anything like that, go for the TARM products because they are even more precise in the beam and even better in scanning. So depending on the kind of application, just try to find a way somewhere here or here. This is what I really recommend to go for. If you got any questions, we can talk afterwards. We can also talk, you can talk to my colleagues. I have actually to leave for the plane now, but my colleagues are down at A4, so you can still ask them any questions you have. And I'd be happy to see you on 14th of January for the intense laser safety and use training. And if you got any questions, just let me know. I hope it was informative to you, and enjoy the rest of the exhibition.
Thank you very much, Norbert.